Nano4Color was a project funded by the European Commission under the Research for SME instrument, a mechanism to increase competitiveness of European SMEs that was part of the 7th European Framework Programme for Research and Development. The aim of the project was to develop surface coating technology capable of producing a multicolor range of thin films that, in an easy approach, can produce variation of the final color of surfaces, improving at the same time the functional properties of the coated parts. Most of the coatings produced for decorative applications use techniques that are generally non-friendly towards the environment and do not introduce additional functionalities to the surfaces, like anti-wear or anti-scratch resistance. Nano4Color was developed to exploit new approaches of the technique using high-beam sources and cluster guns to exploit an effect known as LSPR to produce a palette of colors using a limited number of raw materials for deposition of the coating. Localized surface plasmon resonance is an effect that is generated when light reaches nanoparticles embedded in a dielectric matrix, inducing a collective oscillation of the conduction electrons confined to a volume much smaller than the wavelength of light. The LSPR frequency depends not only on the properties of the nanoparticles, like size, shape and distribution, but also on the properties of the dielectric medium in which they are embedded. Nano4Color takes advantage of the unique properties of nanoparticles to produce nanocomposite films for decorative applications, achieving a wide range of new colors while retaining other properties like hardness, wear, and corrosion resistance. To achieve the project's scientific and technological objectives, a consortium of 5 SMEs and 3 research entities worked during 2 years to develop coatings by 3 different approaches, so that by the end of the project, it was possible to transfer technology to job coaters and to implement the results in real parts. The consortium was coordinated by TNM, a Portuguese SME that spin off from a technological and research center located in Coimbra. They are considered to be a national leader company in advanced material applications and nanostructured coatings in thick and thin films. The company makes use of new technologies for surface engineering like APS, HVOF, PVD and PACVD to produce a large type of coating for functional applications. On the project, they provide expertise and experience on the client demands and participate in the implementation of one of the solutions used to produce new colors. The approach of the concept starts by modeling all the theoretical aspects using computational resources before everything was brought to field. This was made by Inspiralia Tecnologías Avanzadas, located at Madrid and La Rioja, which is a non-profit European institute dedicated to deliver private R&D and innovation services to companies. With about 25 full-time scientists, technologists and engineers, Inspiralia is a leader of multiple projects in a broad spectrum of application areas and sectors. On this project, Inspiralia uses the large experience on optical simulation tools to develop software and models that were able to predict and define coating characteristics. To be able to properly address the problem, 2 industrial suppliers of PVD equipment participate in the project, Alliance Concept is a company that designs, implements and maintains machines and accessories related to vacuum, thin layer deposition and surface treatment systems through cold plasma. On the project, the company supplied information on the typical equipments of its customers concerning thin layers in their own field of activity, like watchmaking and sensors. They contribute to the integration of the new technology in the deposition systems to produce new coatings with a large range of colors. With previous expertise in the use of cluster guns, KCS Europe is a specialist for PVD coating equipment and PVD coating solutions. Based on proven technologies from Kobe Steel Limited, KCS supplies their customers with the highest quality solutions and processes with advanced products for new fields. KCS provides to the project know-how and expertise on the design and development of PVD machinery for the application of the new systems with full production scale PVD units. Benefits of the new colored PVD coatings are expected to be a groundbreaking step in the PVD business for the company, since until now, no economically viable solution was available worldwide. To develop the know-how needed and to set up the thin film produced using cluster gun approach and co-deposition process with thermal treatment, IPN, an R&D center from Portugal, was selected. Working in close collaboration with colleagues from the University of Minho, they were able to set up a wide range of colors by these systems. IPN is a non-profit private organization founded in 1991 to promote innovation and technology transfer, being the main link between the University of Coimbra and the business sector. The Laboratory of Wear, Testing and Materials, providing research and technological services in the area of materials and specialized in modification of surface properties by physical vapor deposition, develops over the project the technology to produce nano-size clusters using ion gun equipment to control the final characteristics of thin films and therefore the colored coatings obtained. At the same time, the approach of thin films obtained by multi-layer deposition was made possible by another R&D center on the project, this one located in Sweden. Material research is one of the key research areas of Uppsala University, and there is strong focus on creating environment for high-level research. The Engström Laboratory of Uppsala has a long history of outstanding research on PVD deposition techniques. The group has a number of vacuum deposition systems for sputter deposition, which were used for film synthesis in this project. Cleanroom facility and the most sophisticated materials characterization techniques were available to work with high PIMs for synthesis of nanoparticles with desired properties for coatings. Alea Metal Experience is a business organization with a constant preoccupation with technology, innovation and sustainability that distributes the last trend of wall and floor metallic ceramic tiles. The company has a clearly defined strategy for obtaining unique products with high value added, both technically and aesthetically. In the project, the products of this company were one of the final application objects, where the technology developed has the opportunity to prove the ability to produce innovative products to the market. PVD Co. was founded in 2002, and its activity consists in the development of innovative solutions using PVD technology. Its core business is the deposition of optical ceramic films or multi-layer for pure decorative applications. PVD Co. also realizes specific PVD treatments for industry and research organizations. On the project, PVD Co. contributes with expertise to apply PVD coatings on decorative surfaces of multiple types of parts and different substrates, adding new colors to the existing ones and enlarging the range of application of the techniques developed. With project Nano4Color, it was possible to use the simpler approaches to obtain a wide range of colors produced by PVD, a technique that merges the aesthetical aspects with functional ones, allowing the applications of thin film to multiple daily objects in many sectors of activity, demonstrated by field tests with different types of coated components. This fact contributes to the competitiveness of the participating companies and to the development of more environmental-friendly industrial solutions. Nano4Color, innovative colors for the future.